Hey guys, this is Larry, and I'm just going to discuss how DNA can be mutated through deamination and irradiation. So through deamination, what happens is the cytosine right here, which normally has an amino group, when that amino group gets removed, the cytosine becomes a uracil. Okay, so normally we had a CG here. Let's just pretend we had a CG here normally. If that CG became a UG because that C became a U, when this parent strand replicates, one of the strands will be fine because that G right here will still base pair with a C. But the U right here will now base pair with an A because U looks just like T and T normally base pairs with A. So 50%, half of all the daughter strands will now have UA, and that will be a mutation. And when that replicates, the A will still be with the A right here will be with a T, and the U right here will be with an A. So we get this mutation. We have a TA or a UA instead of the CG that it was supposed to be. And that's what deamination causes. And irradiation is pretty much the same thing, but instead of deaminating, we're using ROS or reactive oxygen species, and we're changing this G into a different type of G called a GO. Okay, so this H right here becomes a double bond O. And instead of having the GC bond here, the G, which now looks like a T, when that replicates, we have a GC here from this C, that's normal, but the GO will now base pair with an A. And that's where the mutation comes from. So we're going to have a TA sequence and we're going to have a GC sequence. But the mechanism of how it works is essentially the same as the deamination. The results of it are exactly the same. Okay, thank you very much.